Hello students, welcome to the electronics lab. My name is Dr. Farhan Khan. I would be your instructor for the remaining labs and Mariam Hassan would be your TA or lab engineer. After a long break, we would be resuming our labs and we'll start from lab 6. That's where the last lab we did was lab 5. The lab 6 is about bipolar junction transistors or called BJTs. They are made of either silicon or germanium. They consist of two junctions between P and N, unlike single junction diode. There are two basic types of bipolar junction transistors, PNP and NPN. So in PNP, the N-type material is in the middle of two P-type materials, while in NPN, P is in the middle. There are two layers of N-type material separated by a layer of P-type, or two layers of P-type material separated by a layer of N-type. And based on that, they are either NPN or PNP. The central layer, in case of, for example, NPN, it's P, it forms the base of a BJT. External layers form collector and emitter, also called C and E. The structure of BJT determines the polarities of any voltage applied and the direction of the electron or conventional current flow. BJTs are represented by symbols, where the arrow represents the emitter and the direction of arrow represents whether the transistor is an NPN or PNP according to the direction of the current. Here we use a conventional flow direction of the current. So here you can see two symbols. Here is emitter, base and collector. In the NPN, this is the base, which is a P-type material, collector and emitter, which are both N-type materials, and the arrow shows the direction of the conventional current. Objectives of today's lab are to determine the type of transistor, whether it's NPN or PNP, determine what type of materials are used to construct these transistors, whether it's germanium or silicon, to determine and distinguish between terminals of BJTs as base, emitter, and collector, the characteristics of BJT under voltage and current for various operating conditions, and then compare the measured characteristics with the published values by the manufacturer. In part 1, we are given a BJT which is inside a packaging, so it's not straightforward to determine the terminals as base, emitter, and collector based on their position or their arrangements outside the packaging. So we need to determine the terminals as base, collector, and emitter based on a multimeter reading. You can use a diode setting between the two terminals. The terminals that give high readings are C and E. So the other terminal is then base. Then we can also determine whether the material is germanium or silicon based on our reading. And then we can also determine the type of transistor, PNP or NPN, which will be shown during the demo of the lab. In part 2, we would consider and analyze the collector characteristics of a BJT under various operating conditions. So here you can see a circuit which you can construct in the lab with hardware, or you can use Proteus to construct this circuit. First, you need to set VRB and VCE as per lab manual, which are 3.3 volt and 2 volt respectively, by varying these potentiometers. Then record the voltages VRC and VBE and follow the rest of the steps for various VCE as per lab manual. Then we need to determine the collector current IC and emitter current IE and plot IC versus VCE for various base current IB. then you would achieve a plot like this. So where for different IB, you have IC, which is the VCC divided by RL against VCE. In the third part, we would look at the variations of alpha and beta, which are basically the ratio between collector and emitter current and collector and base current respectively. So alpha is IC over IE and beta is IC over IB. For each operating condition in part 2, we can calculate alpha and beta and note the variations under various operating conditions. So now you can get on with the lab. During the lab, you would make the circuit as per manual, set the voltages VRB and VCE and vary them as per the manual. You can record your output voltages and currents in the table and then plot the characteristic curves of the given BJT according to your results in table. Good luck with the lab. Thanks.